Hello and welcome to Aughton Math. In this edition of Aughton Math, we're going to talk about parallel and perpendicular vectors and the dot product. And the objective is to define and apply the dot product to vectors and also define the angle between two vectors. All right, so dot product, the definition, if I have two vectors, vector 1 and vector 2, and I identify the vectors in coordinate form x1, y1 for vector 1 and x2, y2 for vector 2, then the dot product of vector 1 and vector 2 is equal to v1 dot v2, which is equal to x1 times x2 plus y1 times y2, which is a sum. And so the example that I give is vector 1 is equal to, in coordinate form, 4, 2, and vector 2 is equal to 3, negative 1. If I take the dot product of the two vectors, 4 times 3, so x1 times x2 plus, x1 times x2, that's right, times y1, plus y1 times y2. So x1 times x2, 12, plus y1, 2 times negative 1, negative 2. So 12 minus 2 ends up with 10, and that's the dot product of the two vectors, vector 1 and vector 2. All right. Parallel vectors occur when vectors are multiples of each other. So if I have, in the example, vector 1 is 3, negative 2, and vector 2 is 9, negative 6, I can take a constant k, some value. It could be a fraction, it could be a negative value, it could be an integer, positive integer. All of those are possibilities. And in this case, I can multiply vector 1 times 3, and I end up with 9, negative 6. So these two vectors, vector 1 and vector 2, are parallel to each other. So vector 2 is equal to 3 times vector 1. You could also say that vector 1 is 1/3 of vector 2. So some constant value multiplied by both the x and y values in the coordinate form of each of the vectors provides us with the other vector. We know that the two vectors are parallel. So we're going to take... we're going to have a little treasure hunt here. I'm going to give you a list of vectors in coordinate form, and you need to figure out which ones are parallel to each other. So I'm going to pause here while you figure that out. All right, so I've highlighted the vectors that are parallel to each other, 2, 3. I'm not going to go through all these. 2, 3 times a constant k of negative 2 ends up being negative 4, negative 6. 2, 3 divided by negative 2 ends up being negative 1, negative 3 halves. So you can see how some constant is applied to the vector to come up with the parallel vector. All the vectors in red are parallel to each other. All the vectors in blue are parallel, green parallel to each other, and black parallel to each other. All right, perpendicular vectors. If two vectors are perpendicular, then their dot product is equal to 0. All right, so I have a vector u 3, negative 6, vector v is equal to 4, 2. I take their dot product, x1, 3 times x2, 4, plus negative 6, y1 times y2, 2, ends up being 12 minus 12, or 0. Right, so we can see these two vectors are perpendicular to each other because their dot product is equal to 0. All right, so now we're going to go through a couple of problems. I want you to find the value of a if the two vectors 6, negative 8, and 4a are perpendicular. All right, so 6 times, take the dot product, 6 times, 6 times 4, x1 times x2, plus negative 8, y1 times y2, negative 8a is equal to 0. 6 times 4 is 24, minus 8a is equal to 0. A ends up being equal to 3. So similar problem, but I'm going to move a to the x part of the second vector. So 4, 6, and a3. I want you to find what a needs to be in order for these two vectors to be perpendicular. I'm going to pause here. Right, so 4 times a plus 6 times 3, 18 is equal to 0. 4a is equal to negative 18. A is equal to negative 18 over 4. A is equal to negative 9 halves. All right, so let's talk about properties of dot product. U dot v is the same as v dot u. U dot u is equal to the magnitude squared. K some constant times u dot v is the same as k times u dot v or u dot kv, either one. And then u dot v plus w is the same as u dot v plus u dot w. So we'll assume the first is correct without investigating. Let's take a look at the second one. I want you to figure out if u is 3, 4, find magnitude of u squared, then u dot u. I'm going to pause here while you figure this out. All right, so you should get u is going to be the magnitude, I should put this here, the magnitude of u is equal to the square root of 3 squared plus 4 squared is equal to 5. So the magnitude of u squared is equal to 25. And then if we take u dot u, so 34.34, I end up with 9 plus 16, which is equal to 25. All right, so this checks out here. This property, at least on the surface using numbers, does work. All right, so let's take a look at number 3. Some constant k times u dot v is equal to ku dot v. So if u is 3, 4, and v is negative 2, 2, I want you to, and we're going to find an incorrect answer first because I want you to see why ku dot v is not the same as ku dot kv. So let's take a look at u is equal to 3, 4, and v is equal to negative 2, 2. Find 2u dot v and 2u dot 2v. I'm going to pause here while you find those answers. All right, so 2u dot v ends up being equal to 4. So u dot v is equal to negative 6 plus 8. And then 2 times negative 6 plus 8 is going to be 4. So 2 times 2 is 4. And then let's take 2u dot 2v. 2u dot 2v ends up being equal to 6, 8 dot negative 4, 4, which ends up being negative 24 plus 32, or 8. So you can see that these two values are not the same. That's why k times u dot v is not the same as ku dot kv. All right, so let's go back, and now let's check 2u dot v and u dot 2v. I'll pause here while you figure out those values. And I end up with both 6, 8 dot negative 2, 2. Ends up being negative 12 plus 16 is 4. So same as our initial k times u dot v. And then if we take u dot 2v, we end up with 4 as well. All right, so this checks out. We see that this property holds. Okay, then the last is u dot v plus w is equal to u dot v plus u dot w. And I've worked out the left-hand side of the equation for u dot v plus w is equal to v plus w is 7, 8. U dot u is 7, 8 dot 3, 4, which is equal to 21 plus 32, which is equal to 53. So that's the left-hand side of the equation. I want you to work out u dot v plus u dot w. Let's see what you get while I pause here. All right, so you should also get 53. U dot v is going to be 2. U dot w is 51. 51 plus 2 is 53. So this also checks out as well. All right, so now we're going to find the angle between two vectors. I'm just going to go ahead and give you the formula. It's u dot v over the magnitude u times the magnitude v, where cos or theta is between 0 and 180. So cosine theta is equal to u dot v over the magnitude of u times the magnitude of v. All right, so to the nearest degree, find the measure of x, the angle between the vectors 1, 2, and negative 3, 1. So let's walk through this together. So I take u dot v, 1, 2 times, or dot negative 3, 1 is equal to negative 3 plus 2, or negative 1. That's going to be in our numerator. Absolute value or magnitude of u is 5. Absolute value magnitude of v is 10. End up with negative 1 over the square root of 50, which is equal to negative 0.14 repeating. I'm going to take the inverse cosine of that value, and I end up with 98 degrees. So the angle between these two vectors is 98 degrees. All right, same thing here. I'm going to pause while you figure this out. All right, should end up with, to the nearest degree, end up with 73.7 degrees, 74 degrees. You can check your work here by pausing. All right, so now we're going to take another case. I'm going to take a triangle, PQR, with the vertices 2, 1, 4, 7, negative 2, 4, respectively, and I want to find the measure of angle P to the nearest tenth. So let's walk through this problem. I'm going to draw the picture. I connect the vertices. I draw my triangle. I want to find out what the measure of angle P is. Now I need to figure out what vectors I'm going to use. I'm going to use PQ and PR. I need to find the coordinate form of those two vectors. I find the coordinate form of those two vectors, PQ, for -2, 7, -1. So 4, -2, 7, -1 gives us our vector PQ, 2, 6. And then -2, -2, 4, -1 gives us our vector -4, 3 for PR. So I have the two vectors. Next step is to find PQ, magnitude of PQ and PR. PQ is 2 squared plus 6 squared, taking the square root of that value, square root of 40. PR is the square root of -4 squared plus 3 squared, which is 5. All right, so I have PQ times PR, which is PQ dot PR, which is 26 dot -43 over square root of 40 times 5. I end up with 10 over 10 root 10, which is equal to 0.316. Take inverse cosine of 0.316 and end up with 71.6 degrees. That's the answer to the angle measure for P. Right, I'm going to give you another problem, and you're going to figure this out, and I'm going to show you the answer. So I'm going to pause here while you figure out the answer. Okay, let's walk through the steps. I'm going to draw the picture. I'm going to find AQ and AR. AQ is 3, 1. AR is 1, 3. Find the magnitude of AQ and AR. Square root of 10 and square root of 10. Take my formula and apply the values. I end up with 3 plus 3 over 10, which is 0.6, and take the inverse cosine of 0.6 and end up with 53.1 degrees. All right, that's it for this edition of Otten Math. That's it for vectors in Chapter 12. Please join us next time when we talk about sequences and series in Chapter 13.